Welcome everyone, happy to see you again. From this video, we are going to learn about the basics of reinforcement. And let we start. Reinforcement is playing a vital role in any kind of structures. Bars, wires, fibers, strands, or other slender elements that are embedded in a matrix, such that they act together to resist forces, which is created and carried by any kind of structural members. Most of the concrete used for construction is a combination of concrete and reinforcement, that is called reinforced cement concrete. The steel bars used in reinforced cement concrete are called as reinforced bars, or rebars. There are two types of reinforcement. Plain steel bars. This type of steel is widely used in olden days. Yield strength of mild steel bars are 250 Newton per millimeter square. Plain steel bars are solid circular in shape, and no ribs are present over the surface of the steel bars, and the bond between concrete and steel not good, because of the absence of ribs. As well as, the yield strength of steel reinforcement is required much more for the high-rise buildings. So, this type of steel is not suggested for the main bars of any structures. Tor steel bars or ribbed bars. Nowadays, it is used widely. Maximum yield strength of 600 Newton per millimeter square is used in Indiana construction, and good bond between the concrete and steel. The ribs are present over the surface of the steel, throughout the length of the steel bars. This type of steel is suggested for all kind of high-rise buildings. Reinforcement is very essential for any type of concrete structures. Because every structure is subjected to compression, tension, and shear force, due to the dead load and live loads, which is acted over the structures. But the concrete is good in compression, but weak in tension. Positively, the steel bar is good in tension too. So as to avoid the failure, due to the tension force in the structure, the reinforcement bars are installed before the concrete sets. There is different grade of steel is used in practice, which is given below. Mild steel is having Fe 250 Newton per millimeter square. High yield strength deformed bars are having Fe 415 Newton per millimeter square and Fe 500 Newton per millimeter square. Thermomechanically treated bars are having Fe 415 Newton per millimeter square, Fe 500 Newton per millimeter square and Fe 550 Newton per millimeter square. The numbers, like 250, 415, 500, and 550 represents the yield strength of the steel bars. Diameter of steel, with its weight are given below. Every civil engineer must know this detail. From the steel bars manufacturing company, they will give the ordered quantity of steel in a bundle format, which may vary from 1 to 20 numbers of steel in a bundle, which is varying, based on the diameter of steel reinforcement bars. Sometimes, numbers in a bundle may vary with company to company. Average number of steel bars on a bundle, with respect to its diameter is given below. From this video, what I learned is, unit weight, and density of steel reinforcement bars, and the importance of reinforcement in concrete structures. Reinforcement is the most essential part in every high-rise building. Reinforcement bars is available in various sizes with varying physical properties. Based on the need, and construction material, the properties and size will be suggested. Even though the reinforcement bars are making lot of advantages to a concrete structure, environment is one of the biggest obstacles for the reinforcement bars to maintain its property. TMT bars are most preferable for residential building, because of its excellent ductility, weldability, and good resistance against corrosion. Thank you everyone. If you like this video, thumbs up, and subscribe my channel and keep sharing.